Well, good morning, everybody. I'll come back and introduce myself here in a moment. We do have, a full agenda today, and we want to make sure we give plenty of time to all of our presenters today. What we typically do in this venue is kind of go around the room so our speakers have an idea of who the audience is and who you're representing today. And so since we're about a minute or two early, why don't we go ahead and get started with those introductions? And so why don't we start over here on the left side. Robert, do you mind going first this morning?
Yeah, sure. Good morning, everybody. I'm Robert Pinkard. I'm the environmental manager at AIndustry.
Corey?
Fuller Singleton, environmental engineer, AIndustry College.
Joey Jernigan, H&E Equipment Rentals.
Okay.
Eddie Kirk with Monic, IoT factory manager.
Hey, Eddie.
Utility Management Services.
Ron Hoffman, Utility Management Services.
Ron?
I'm here, faculty at South Alabama.
Okay, why don't we go to the back now?
Hey, I'm Jonathan Boone with Mater Bearing, outside sales.
Okay, John?
Marty Lynn, University of South Alabama, also Gulf Coast Environmental Laboratory Center.
Okay, great.
Sherry Norland, Servpro, Mobile County.
Okay.
Philip Ansel, CEO, co-founder at AI Ops.
Nice.
Curtis Ryan, co-founder at AIndustry.
Mike Hendricks, the health process equipment.
Good morning, Mike.
Paul Naiman, geologist with Atlas Technical Consultants.
Okay.
Chase Tierman, EHS engineer at Hawaii.
Okay, Chase. How about we come over to Connie?
Hi, Connie Busness, EHSSQ at Avonic.
Philip Long, CEO of Business Information Solutions.
You hear from Philip?
Tom Sahota, McBearing, Alabama.
Peter Holzapfel, independent infosec consultant.
Skokia Bansal, environmental engineer project manager with SCS Engineers.
Hi, I'm Virginia, CEO, co-founder of NIAD AI.
And I'm Chris Braithwaite, Virginia's co-founder.
Okay. And then Jennifer, you've met. Sabrina, you want to?
Sure. I'm Sabrina Alexander, and I'm with Proxy Public Relations. We help with their PR marketing.
Keith Stevens, I'm the digitalization leader at Hardware Control Automation.
Sean Price, Site Controller, BASF.
Sean?
John Shoemaker, production manager at BASF.
All right, thank you, John. So my name is Steve Stewart. I have the pleasure of serving for the Partner for Environmental Progress Board of Directors president this year. Work closely with Sabrina and Lindsay and Jennifer. And so it's my pleasure, my honor to be with you guys again this morning and to talk about our seminar and to learn a little bit about artificial intelligence. I was on a conference call with our team a few weeks back, and we were stuck with trying to how to word something in a report, and we had like 5 or 6 team members on there. I don't know, Koki, if you were on that call or not, but I was like, nobody could come up with a good phrase, and so I was like, well, I'm going to ask Microsoft Copilot. And so sure enough, I typed in, how to word this up, and Microsoft Copilot came up with this great suggestion. And I basically said, you're all fired because this, you just been replaced. No, it's a joke, but it's very intriguing. It's obviously something that's I think going to make a lot of operations more efficient. And part of why we want to hear about it this morning is because of the sustainability aspect as well. So very excited. I'm going to go over our list of speakers here in a moment, but I did also want to acknowledge our sponsors this morning. We've got the Solid Waste Sustainability Hub you see up here on the screen is led by the University of South Alabama. I don't know if you guys know Dr. Wu out there with the Civil Engineering Department, has been very much focused on sustainability. It reached out to us and wanted to partner with us and offer sponsorship. So we couldn't be here this morning without those types of sponsorship. So the hub that they've developed is focused on recycling and circularity within the community, education components, and that's being funded through Environmental Protection Act grant. So we're very thankful with Dr. Wu and the University of South Alabama being part of our sponsorship team this morning. You also see up here the Mobile Chamber, who's been a longtime partner for Partners for Environmental Progress, as well as Ransom Recycling. there in the Chickasaw area. Ransom has been a part of our membership and our team, and they are actually offering e-waste recycling today here at this event. So if you guys have any electronics that you're trying to discard, they have a really great program there at Chickasaw, and they actually even will come and pick up if you have enough electronic waste that you need to discard, and they'll even provide certificates of destruction for their e-waste that they reprocess. So very thankful again to all of our sponsors today. I am going to talk a little bit about our speakers. We've got several speakers lined up today, and what I'm going to do this morning for the sake of time is go through their bios, and then we'll get started with the program, and I'm going to ask that they'll come up, and we will, I think we are taking questions at the end of each presentation. We'll try to keep those somewhat concise. So be thinking about your questions, be ready to ask those questions as time allows. And so our first speaker this morning is Dr. Aviv Segev, professor at the University of South Alabama in the School of Computer Science. He received his PhD from Tel Aviv University in Technology and Information Systems. And his research interest is looking for the DNA of knowledge, an underlying structure common to all knowledge through analysis and knowledge models in natural sciences, knowledge processing, and natural and artificial neural networks, and knowledge mapping between different knowledge domains. And then after Dr. Aviv, we've got John Shoemaker from BASF, who is the Asset and Reliability Manager there in their McIntosh location. And he's been in the chemical and mining industry for over 26 years. He's had various positions in operations management in several of the surrounding states. We also have with us Heath Stevens. He's the digitalization leader at Hargrove Controls and AMP Automation. He's a certified member of the Control Systems Integration Association. Also has over 27 years experience in chemical engineering, process safety, automation and controls, and has extensive experience in batch specialty chemicals as well as refining, pipelines, pulp and paper. And so his experience also extends into startups, project management, team leadership, and facilities. And so he's helping his clients implement digital solutions that deliver on the promise of Industry 4.0 through data acquisition and the latest analysis tools. We also have with us this morning Philip Hansel, the CEO and co-founder of AI Ops. It's a company dedicated to bringing AI controls to the factory floor through advanced edge-based software and hardware solutions. Guided by a core philosophy, Philip aims to harness AI to enhance efficiency in operations and engineers, reducing their workload instead of adding to it. And with over 15 years of experience in control systems engineering, he possesses the expertise to identify valuable opportunities for the AI industry and deliver robust ROI-driven solutions. We also have Thomas Ciota this morning from Alabama Power at Plant Berry here north of town. He's their fuels manager in AI and AMP. Barry currently, Tom currently leads the team of innovators at Alabama Power responsible for advancement of technology and power generation. He and his team's committed to achieving excellence through utilization of AI and other technologies. Since 2008, Tom has held a number of roles at Plant Crist in Florida, as well as Alabama Power. He has a degree in mechanical engineering from University of Florida and holds an MBA from Florida State and is currently pursuing MS in mechanical engineering at Georgia Tech. We also have Virginia Zeptowski.
Very good, yeah.
Oh, wow. I'm from Alabama, so I can't pronounce. So, Virginia is the co-founder of NYAD, a new startup applying machine learning to industrial wastewater treatment to reduce wastewater pollution and decrease plant operation expenses. And then lastly, but not least, Philip Long is an IT professional, entrepreneur, and certified information systems security professional with over 25 years experience, been the owner of 5 businesses, including Business Information Solutions, which he founded in 2001, Philip is committed to providing technology and security solutions to Gulf Coast businesses. So that's our lineup today. Thank you again for being here. We will have a break here after the first few speakers, but at this time I'm going to ask Dr. Aviv to come up and begin his presentation. Thank you, Dr. Aviv. Oh.
Okay, so I was told never to start a presentation with an apology or a joke. So people do ask me, is AI taking over the world? So yes, and I'm sorry it's taking so long. So let's try and figure out where is this kind of scare coming from. So, well, most of it is science fiction. If you have your favorite movie here, you're from the 80s, 90s, it started to get a bit more scary, the AI, and it continues basically till today. So this is most of the conceptions we have is based on those movies. That's what people are really afraid of, AI trying to take over the world. So hopefully today I'll be able to convince you yes or maybe no. So let's see, what are we really trying to do? We're really trying to imitate this part of our body. It's relatively small, and most people view it as the main part that analyzes our, well, we could call it thinking. And, well, we don't really know how it works. That's kind of odd. But we do know it usually makes rational decisions, or decisions that actually we hope to benefit, or not shooting ourselves in the foot. And we could view it as mostly, we want to just reverse engineering. That's quite a lot of companies trying to reverse engineer it, although we don't quite know how it exactly works. But if brains works, we would be able to imitate that the same way that airplanes work. So to do it, most of the people do agree it does two things. One thing is it's able to store information. That's what we are able to do with our brain. Another thing is we're kind of able to simulate or look at a glass ball and try to figure out what are future possibilities to do that. So that's one way to look at what we're trying to analyze without fully understanding or being able to, what we want to reverse engineer this part of the body. So if we can't do that, what do we want to do? We want to be able to define AI. So how do we define AI? Well, we want to define it as, well, imitating humans or systems that they work. So if we don't know how humans actually think, what we're going to do is kind of trick the viewer and get the same input he has and get similar or even better results, and then we'll call it AI. And that's a system that simulate what humans either think or how they act. And we can actually view it as also acting rationally. So those are the areas that we are trying to get to. And now let's see the history of AI. I actually got asked a couple of times, what did you used to do before AI came about 2 years ago when it appeared? So actually it came about in 1950s. 1950s was a guy, Turing, you might have heard him from other places also. And he came up and said, well, let's try and figure out a test to see if a system is actually intelligent or smart. A lot of the science fiction movies, after about 20 minutes, all of a sudden you realize that person is a robot. In Turing, it was a bit less formal or Hollywood-like. It was a system that basically nowadays called a Turing machine. All it is was you used to sit and type a question, and somebody on the other side answers the question. Now, the trick is, are you able to trick the human or interrogator into thinking that the machine or person on the other side is actually human? If you are, then you have an AI system. Now, the theory said in 1950s that by the year 2000, we would have 30% chance of imitating that, or actually being able to fool a person for 5 minutes in 30% chance of doing it. And in this paper, he actually came up with all the main concept of AI, such as the knowledge, reasoning, language understanding, and learning. This test is not actually reproducible. You can't actually, if you did it once, you can't do it again on the same human being. But it's a nice idea. Any ideas we can actually do it, or were we able to do it by year 2000? Yes? Well, actually, yes. They were actually able to do it in 1964. Somebody, professor there, tried to created a psychotherapist. What does it do? Any question anything you come up and start typing, you come up and say, well, I had a bad day. Would come and ask you, why do you have a bad day? My boyfriend, girlfriend, spouse said something. What did they say? And this is how the conversation would continue going and going. And this guy walked into his office, and his secretary asked him to leave the office because he's having a private conversation with the machine. So then he realized it's kind of went out of what he expected, and actually most of his academic career he apologized for actually ruining this idea of a test. So yes, it's able to do that. And if we continue, they had quite a few years that were really successful. They were sure they're going to have a meeting and solve all the problems in AI. If you play checkers now online or anything like that, they came up with a machine that actually learns it. They had an idea that all their mathematical issues they will be solved also. So that was those years they were sure it's going to be solved very quickly. And one of the things was in that 1956, they said within 10 years, they're going to win the game of chess. Why chess? Because chess is relatively difficult. And they were wrong. It took actually 30 years. And yes, Garry Kasparov, which was the world leader in chess at that time, lost to, well, Deep Blue or IBM. That was a main change at that time. And then Garry Kasparov actually lost it. And he said, I heard him talk, he said he's not a fair loser. The agreement was that he would get a good couple millions of dollars for doing it. He was really upset that the machine cheated. The machine, they had to reset the computer, and this way the machine had more time to think than he does. Usually the machine doesn't think when it's offline or turned off, but again, he lost some of the games, and his feeling was it's almost there, it has some intelligence, and you can actually smell it if you ever smell intelligence. I'm not quite sure about that, but that was his feeling. So this was one major game, 1997. Another one that did was the game of Go. Game of Go was 2016 and 17. And in 2016, I was in Korea. They asked me, could you actually, it was Lee Sedol, was a Korean guy that lost. And they asked me, could you talk to the radio about, I was a bit hesitant to talk to the radio about a game like that. A year later, a Chinese player, KG, lost to it, and he was the world leader. And then they asked me, could you talk? And they had a whole set of questions. The last question was, since the person from Korea lost only 3 out of the games, and the person from China lost all 4 games, does it mean that Korea is better than China? And I told them, no, it's a different system. And they never invited me for an interview again. So if you're wondering how it looks like, this is how it looks like when you're losing. Your whole career is built on playing this game. Okay, so this is, yeah, that's when the person realizes what's going on. And how did he do it? That was even more interesting. The media said that it made a move that really shocked him. The guy was so shocked, it kind of lost its way. And then they analyzed the move. Was that move really great? Did it give him a huge advantage all of a sudden? And the answer was no, it did not give him a huge advantage. Did it give some disadvantage? Also, didn't give some disadvantage, but it was an unexpected move. That's what happened. It was unexpected move that gave the same odds to do, but it wasn't played before. So you would be able to calculate that it's not played before. Theoretically, it might be a better chance of winning because you don't have the values for it. And the guy saw it as a way that actually totally shocked him and got the guy basically lost on this game. So we continue all the way to year 2000, and from there on it explodes. There was a short time of, not quite short, 15, 20 years, which had AI winter. What happened there, people at AI overpromised. They promised that they will have automatic machines that will be able to replace doctors. A lot of people lost their money in those years, and the whole idea was that we would be able to move that quickly. Was actually didn't work out. By the year 2000, computers became stronger, and the theories were a bit more developed. So those were some of the information that came about. Now let's see a few terms that come out. Well, AI has, and machine learning, and some people say AI, machine learning is more important than AI. Actually, machine learning is a part of AI. Machine learning is the idea that we can have the machine learn some of its method or algorithm, if you want, by itself, versus whether you view AI as a whole set of algorithms or methods to perform a specific task. So the idea is also using the neural network, or let's look at the human brain. The human brain has neurons. Let's try and build something similar to that. And if we want to build something similar to that, here comes the problem. How do these neurons work? So if we want to figure out how those neurons work, you have a couple of billions in them. We can go to what's called cognitive science or psychology or neuroscience, which looks in the microscope and tries to figure out. So 1960s cognitive science or revolutionary approach, and says a person is not born with a way of thinking. It actually modify the way of thinking, which looks a bit odd nowadays, but that was what it's believed beforehand. And then we have cognitive neuroscience, which looks at the brains with very big microscopes and try to figure out what it does and how it changes. And both of these areas have something common with the area of AI. We all don't know how the brain works, and they can't totally explain it. So what we're trying to build is theories that similar to the results of what a human does, and what AI does is tries to bypass it. So that's the area of that we're looking at, machine learning. And now there's another term that appears quite a bit in the media, general intelligence. So what's general intelligence? Sometimes it's also called, general intelligence is ability to outperform human beings in everything. Okay, outperform them in anything that's, well, economically valuable or anything that we can actually measure. And that's also called strong AI. Strong AI, other people view it as sentience, being able to, or consciousness, being able to know that it actually exists. There is example of how to lose your job with actually saying that it does, and a person in Google lost it because of those. And another approach is weak AI. Weak AI means you can have only a specific area that you specialize in, and you outperform humans in that. And us in the world right now, we are actually weak. We are in this area and this area only. We're not really close to being able to replace humans in everything, but we can outperform humans in a lot of areas. So that's with those. And another one term that comes up a lot in the news is neural network. So if you've never seen a neural network, here is how it looks like. It doesn't look too impressive. It has a whole set of inputs that we get from the environment and also a whole set of outputs. For example, I have a car. Let's assume I have only 3 inputs from the car that I can have and 2 outputs, drive or stop. The part in the middle is the hidden part in the neural network, and that's it. That's the whole neural network, or simplified way to use it. Those lines in the middle that connect them. Again, these number of inputs have to be defined by the person who develops the system. So does the output. The hidden part you can actually build, and the learning is deciding how important are each one of these lines. So this is the whole idea of neural network or machine learning in a simplified approach. Now, if you heard the term deep neural network, then this is what a deep neural network looks like. Exactly the same as the other one, just deeper. So it has more than 4 or more lines or rows or neurons in the middle. That's a deep neural network. And again, all these nodes do is decide if to pass the information forward or not. Okay, that's again, that's all they do. They look at all the inputs and then decide if to pass the information forward. So this is a neural network, and here is the deep neural network as an approach. Again, it's the same thing, just more depth. And again, this was allowed because we have more computing power today, and we're able to do that. Another term that comes a lot is convolutional neural network. So I'm not going to show you how a convolutional neural network looks. I'm going to show you what it does. So what it does is it's very good in analyzing pictures and deciding what it is. So here is an idea what it is. If I ask you what a bicycle is, maybe you'll give me a lot of pictures that there are. But if you ask me what parts are in a bicycle, you might say, well, we have at least 2 wheels usually, or only 2 wheels. We have some bars that hold it, some place to sit, and some part that belongs to the chain. And if I ask you, okay, what are the parts that you sit on, you might break it down into smaller parts. So now all I have to do is scan a picture and see if you have something that looks like a wheel. So it's going to, what's called convolve, scan the whole picture and see how many wheels do we have. If we actually find 2 wheels, then maybe it's a bicycle. It could be other things also. If we find all of these, that's one way, and then we can generalize it also. So now we can scan any picture of any bicycle that might be in the picture and be able to detect it without actually explaining to you what it is. And the system can actually learn those terms. So that's with that area. And now let's move to who are the main players. So the first one is obviously OpenAI or ChatGPT, one of the main influencers in this area. Another one is Tesla, which participates in it. Google is also trying to put in a lot of funding, and so is Meta and Apple and NVIDIA. So notice that our 2 of them at least could be defined as hardware related, and other ones are hardware or software related areas that are working in this, or the main players in the AI industry. Now, what about the DoD? I just grabbed a few recent postings on the DoD in the area of AI. You can see it's very much involved in it, and also funding a lot of research and work in AI. So obviously the DoD does also. And here comes the part that what do I do? So yes, what keeps me away from sleeping at night is, does knowledge have an underlying structure for the whole knowledge itself? Like, where did the idea come from? Biology has DNA as underlying structure. Chemistry has the chemical tables. Physics has those weird equations. does knowledge have also something that's fundamental that we can take it from one area to another and has it as a basic structure? So I view it as knowledge modeling, designing it, and then also processing. And actually, if you can map one knowledge from one domain to another, it'll be even better. So those are some of the areas that we're looking at. What do we have? So research that I've had before, the weirder ones were, can trees think? And if you're thinking if it's a decision tree, no, we're talking about the trees outside. And we're talking about connecting all the, can the trees, each one by itself does not have neurons or an ability to think. But if you connect them all together as a forest, can it actually make decisions? And I had to change the title of the paper quite a few times because it actually had, can trees think in it? And as soon as I took it off and just left it with communication in the forest, it got accepted, and the top botanist actually, once it got accepted, it said, how dare you say trees can think? And I told him it's not a single tree, it's the whole forest can communicate and make a decision. And by the way, if you're wondering if they can communicate, yes, a person in biology found out that plants can communicate, and if you're actually hurting one plant, another plant can actually send a signal to it. And the person, as a reward, never got funded again and had to open a bed and breakfast. So it looks like a very promising area to continue researching. Rest of the time also, can you predict research, which area we're going into? And current projects. So we have two main projects right now. Counterfeit chip detection. What's counterfeit chip detection? You have those electronic chips, some of them are real fake. What is a fake one? You save $10, $15, and then you can put it in your electric guitar or a missile. Now, the Department of Defense is more worried about missiles flying in the wrong way, so they're actually funding us to be able to detect it without image processing and without distracting or destroying the chip. The other ones is drones. We have a whole set of drones that are totally autonomous, flying inside the building, inside our lab, and they put something like 20 people to come and view it. You're welcome to see it. What they do is they identify the bad person in the room and being able to track it and circle it. And we actually have a water gun to use it in that case. So that's, with those, you're welcome to come and see a demo of that. So should I be scared? So I got a whole list of topics if you should be scared of or that. So obviously the automated, the job loss. By the way, they said the same thing about creating clothing automatically instead of doing it themselves. So it didn't totally destroy it. Deep fakes, obviously also. Algorithms that are biased, and well, automatic weapons, can't argue with that. We are trying to help make them in that case. So these are some of the areas that it might be work with you. But again, if it's up to you to decide if you want to or not to be able to be scared in this area. So I guess that's about it. And I guess that's it. We're just left with AI, I guess. Questions? Yes.
As an economist, I think it's easy to see the benefits derived from the usage of AI, right? It's more efficient, or it can improve margins, et cetera. But from your view, existentially, do we have a concern of like losing our humanness in this? Or is that even a concern to have?
Again, the GDP actually grows. Overall, it grows more. Yes, some people would have to change their jobs. Humanness, how people are really afraid of it. What would happen, let's think of an extreme one. What would happen if we don't have to work? All the machines would do the work for us. Would the humankind actually vanish? And actually, they had research on it, and the answer is no. If it doesn't happen all of a sudden, people will be able to adopt and have more free time. So that's a question of our humanness. Again, do we need it all for each of the tasks? But here in this case, the extreme one, if we're able to adopt in this case, then I assume we'd be able to adopt like any other industry revolution that happened before. We will be able to adopt to it. And avoiding it is kind of hard because if we don't do it, some other country would move forward with it. Yes.
I've heard this before. I'm curious what your thoughts on it. Is there any worries in your mind about like the whole dead internet theory of where we start getting to like generative content, where the majority of content we find online ends up being generated from our models and not actually human-made?
Yes, we could generate models from machines. Again, at some stage, most of the data nowadays still comes from humans. Let's take the area of Hollywood that has movies. Let's assume until now they try to do the special effects with that. You're not allowed to create a total person that imitates another human being, but you can actually generate different movies. Does it limit our willingness to go watch the movie? Just it was generated by a machine. Would you disagree or not want to be able to view a movie just because it was generated by AI?
Music is generated by synthesizers, so I still enjoy it.
Okay, so that's okay. Okay, so we have one more question. Paul? Yes.
One thing we're probably familiar with is the weather models that predict whether a hurricane will form or not. Are those considered AI? And the second question is, when's Skynet taking over?
That's yes, that's taking a while. Yes, I do apologize for it. Yes. Yes, whether it creates AI, if you're using the same algorithm again and again, it's based on that. If you're basing it on predicting the ability or imitating the human ability, if you're just putting it and it's a machine and pops out the value, I wouldn't call it AI. If it generates or can speculate different possibilities of it and generate the output by itself, you're not actually telling it what to do step by step, then you could come closer to AI. And again, it's up to you. You can always say it's only engineering and not AI if it works well. So, okay, that's.